The kick is up. This is for the game. And it's...
Who won? Not your observability solution. Hydrolix powered observability lets you catch the problem before it affects your customers. That's why the biggest brands trust us with the highest stakes events. From the big game to the biggest matches to the games. When performance matters and your reputation is on the line, Hydrolix delivers game-changing observability for less. Every time.
Hey folks, welcome to another episode of Inside Hydrolix. I'm your host, Josh Robinson, and today I am with Katherine Johnson again to talk about the Super Bowl of 2025. First of all, first things first, go Birds. So, Katherine, how are you?
I am great. How are you?
I'm fantastic. As an Eagles fan, I'm greatly appreciative that there were no hiccups during the Super Bowl. We could watch the Kansas City Chiefs lose in clear definition. I was excited. I want to talk to you about what Hydraulic's position was uh, during the Super Bowl. So,
Mhm.
like, let's start big picture. Like, what does it mean to be the sole multi-CDN observability provider for Fox during the Super Bowl? Like, why is that a critical responsibility?
It's so CDNs are what help push content to end users.
Mhm.
So the content gets pushed all the way out as close as you can to end users. Not everybody is watching the same stream, so there's like copies of it everywhere. Uh, CDN or content delivery network providers all have their own specialties, just like any software, like different types of networks, different parts of the world where they're more prevalent. So to deliver a global event like
Mhm.
that and to really be considering everybody's quality of experience that's watching, you almost have to have multiple CDNs in order to do that. So what starts getting interesting there is that uh, companies have contracts with CDN providers about how much bandwidth they can use.
Mhm.
Um, and it's also completely distributed. You have, multiple different vendors that are doing different things. So being able to see in one picture what's happening with all these different software, or I guess they're more infrastructure providers across the world, and see like what anybody's given experience is to make sure you don't have, you don't get flamed on Twitter like worst Super Bowl ever or something like that, right? Like we've all seen sporting events where it did not go well and
Mhm.
Twitter or whatever social media lights up with that.
Mhm.
Um, so it's really important to them to be able to deliver quality experience to everybody that was watching the game. And something that was unique about this one was that at the end of last summer, they decided to broadcast it on Tubi.
Mhm.
Tubi doesn't have a paywall.
Right.
You have to be a subscriber. So there was they really didn't know how many people were going to show up. They didn't know what the scale was. Like it all very much depended on how the game went, all of that sort of thing. So for them to have visibility beginning to end of the event to see what the actual customer experience was super important to them in order to, have a success to, see to not have any bad press after the fact.
No, that's awesome. I think just like you said, with them streaming it from, Fox and Tubi, can you kind of put into scale like what that looks like, especially having 24 million unique streaming viewers and 1.4 petabytes of data per day? Like, how does that compare to like a typical enterprise?
It you don't see that scale most of the time,
Right.
which actually it makes it really hard to test for it too, right?
Mm.
There's not a great way. Anytime you're trying to test scale, it's really hard to create, real representative set of data or traffic to do that scale. So, like we have some customers that'll do hundreds of terabytes a day in data that they're sending to us.
Mm.
But the scale of of this particular Super Bowl was massive, and we were, in fact, ready for 3 times the traffic, because it just depended on how the game went. So, starting up front, it was like, there could be this many viewers or there could be this many viewers, and it was a really wide range, that we needed to be prepared for.
Sweet. Yeah, even in some of this, like with our blogs or things that we talked about, even in the docs, we mentioned the phrase like kaiju clusters, which is a
Mhm.
really awesome thing, right? Can you explain like what the architecture
Yeah.
looks like and like why the workload separation is really crucial for this event?
Yeah, so, kaiju, I don't know the exact my understanding of the, term kaiju is like a transformer when, like, all the transformers come together and make, like, a bigger transformer.
Okay,
Is that
yeah.
like Optimus or something? Or
Yeah, I think depending on what you watch, yeah, it could be anywhere from Transformers or Power Rangers.
yeah,
Well, most people look at it got like Godzilla, but yes.
right, yeah, so
Yeah.
it's when a bunch of things come together to work together as one.
Uh-huh.
So so this event ran on AWS,
Yes.
because of the unknown amount of traffic, and because for AWS, this is already a big event, right? There's people that are running all sorts of other things in parallel to the Super Bowl that take up compute in AWS. We were concerned about having the right amount of compute per region even, that we needed in order to support the event. So because we didn't know how large it was going to be, our architecture allows us to run in multiple separate clusters operating as one. So we can use compute from a bunch of different places, but it still operates like one cluster. So data is still going into one place. We're still querying against one place, but we have the compute separated. In AWS for this event, there was consternation is probably the best word I can think of about, do we have enough compute for the max that we're expecting? So in order to accommodate that, we set up clusters in multiple regions for a couple of reasons. One was to handle the traffic, but also if there was, the customer asked us to be ready for, like, if a full region failed, what would happen? Right? And so that was also part of this architecture, is like, well, we have the whole thing running someplace else as well, so we can fail over between those. But really, it was to separate out the compute so we weren't completely sucking up all the compute in one region. We were
Right.
distributing that among regions because it was pretty, for this event, for that scale, we wanted, some pretty hefty machines for that. And so Kaiju is basically several Hydrolix clusters, potentially across different regions. Sometimes they might be in the same region, but they can be across separate regions acting as a single cluster.
Sweet. Now, with all this architecture kind of set up, you were able to achieve 5 to 10 seconds time to glass
Mhm.
from data ingest to visualization, right? So in a live event like the Super Bowl, why is speed so critical? Like, and what engineering challenges did you have to overcome?
The speed's really critical because you want to see the problem before your customer does. And at this scale, that's really challenging. So going into this, the customer had said, we've never been able to do this before. You probably can't do it either, right? We started from that spot because they tried and it's hard, and they didn't want to sample the data. So it's not like we can start saying like, hey, we're gonna sample out everything that's a success, because then you don't get a real view of the traffic. You see all the errors and you see all the problems there, but you don't see, the patterns of the successes, like where are the viewers coming from, through
Mm,
which networks are they coming, what is average, or not average, but like median, response time on any given stream request to a customer. You don't um if you filter all that stuff out, you don't have a complete view of what's happening. So it was really important for them to have that. In terms of challenges, you have to really start looking when you talk about data at that volume, like everybody likes to be, say it's unstructured, you just toss it in, you can figure that out after the fact. But at that scale and that volume, you really do need to try to compute a bunch of stuff at ingest because querying data at that scale is hard. And the more that you have to do in those queries, like if you're doing regular expression matching or anything that's really computationally intensive, doing that, on a couple of gig of data is no big deal. Doing that on hundreds of terabytes of data is a big deal. And when we go to query, we're still limited by physics. Like there is still a limited amount of memory and a limited amount of
Mhm.
compute, which is, why we had to split clusters up to begin with. So we really wanted to take and do as much of the computation at ingest time, meaning it just goes into the database into Hydrolix already processed, instead of paying that at every single query. So you pay the cost up front once to do, whatever regular expression matching you want
Mhm.
to do. And then when you go to query it, that data is indexed. We're doing exact string matching, so the queries end up coming back a lot faster. So that was one of the challenges. Is just like, at that scale, the techniques that you use to query data change. Um, that is just kind of part of it. Uh, I think the other challenge we had at this bringing different CDNs together at this scale was normalizing all of the data into not just a single model, but like the same units and measuring the same things because all of the providers send different data. So, like I mentioned, they all have sort of their different niche in the industry, like where they are, what they do, and so um, you can take that data and normalize it, but it takes a little bit of work to get it to the point where it's like this is representing exactly the same thing as this field from this other vendor, like whatever transformation you have to do. So again, like you don't want to have to figure all of that out at query time, right? You just want stuff to come back. You already know the things that you're looking for. So I would say that was another big part of the challenge is just making sure the data was correct, accurate, and represented the same thing across all of those different vendors.
Yeah, and that's awesome. I think when we talk about multi-CDN usage, and even like edge computing and things like that, like getting all of that information into the same place so that the data essentially tells a story. Um, in that, doing a live event, there were requests for specific data during the game, right?
Mhm.
Can you paint the picture of like what the war room atmosphere was like and how like real-time observability enabled quick decision making?
Yeah, so it was pretty heads down. We had a couple of game days ahead of time to practice.
Okay.
But again, like you can't simulate that scale. It's just impossible. We started very early in the morning, like well before the pregame show started.
Mhm.
And so we were seeing a ramp up all day of viewers. And so when the game actually started, it was kind of a non-event, honestly, because we were already like monitoring and paying attention to what was happening. Um, the room's full of vendors and folks from Fox that were, had a vested interest in that going well.
Mhm.
Um, and so there was a lot of attention. We had a dashboard up that there was a lot of attention being paid to that. And so that needed to be as real time as possible for the executives. That's where that 5 to 10 seconds to glass really mattered. They wanted to see the problem as soon as it happened. Um, we did a pretty good job of anticipating most things. There were a couple of things, that happened that we weren't it was like, why does this thing suddenly have, a lot of, 404s?
Mhm.
There was one place where, like, we kept seeing a lot of 404s, and we had to dig into, uh metadata basically embedded in this very long path, the request path of the users in order to pull that out, which did require regular expression matching. But we had already narrowed down, which you can still do with Hydrolix, but we had narrowed down what we needed to do the regex matching on to
Mm,
like, we know it's between this time and this time. We know it's on this network. We know that it was a 404. We know all of these types of things. I think we knew like the types of devices we were seeing it on. So at that point, it was really straightforward to go in and do that query. And we had a separate set of query compute to do that on. So it didn't impact anybody else's uh, access to the data or potentially impact the query compute. Like we just had it completely isolated on its own. Uh, but it was pretty, I mean, it was very quiet. It was like, hey, why is this error happening? I don't know. Let me go look. Let me see what we can find out about that. Um, and once we identified it, it was like, oh yeah, it's not a big deal. That's just a, problem with the client requesting something that's old,
mm,
that's maybe isn't there anymore. But it was, I mean, honestly, folks were heads down most of the day, everybody that was in the room, until after, I would say like after halftime, the mood lightened a little bit.
yeah,
It was like, okay, we made it halfway there. We made it through Kendrick Lamar. Like as long as nothing major happens in the game, like we're smooth sailing from here on out, which was the case. Um, yeah, so I mean, it was very serious, um, but pretty chill. Like there wasn't like, I would have thought of not having done live events before that there would have been a lot more like hair on fire kind of stuff going on.
yeah,
But because we had the 2 game days leading up to the event, we had kind of like a dress rehearsal with the championship games. We've been
mm,
through similar stuff
yeah,
and like we had done everything that we could to prepare. Like the
gotcha.
only thing left that was unknown was like what was going to happen during the game. But everything else we had prepared for, which made, the day was actually pretty calm. It was just a long day.
Sweet. When now being able to create different views for different stakeholders, executives wanted kind of like the big pictures, engineers needed the queryable insights.
hmm
How do you architect a solution that serves both without compromising performance?
That's a great question. So, the way Hydrolix is architected, we all of our ingest and all of our queries completely stateless. So we're not dependent upon, something holding on to data in and being available for the next query. We rely on object storage for all the storage. And so we're really relying on the scaling and the availability and durability of object storage to give us the access to the data really quickly. So that's one part of it. The second part is on the compute side. So it's stateless, but we still need compute to do the querying. So because it's stateless and because it's object storage, we can set up multiple, we call them query pools, but it's effectively like different sets of compute that can be used for query where we can isolate types of workloads. So you can have one set of query compute that's not as highly powered, another set that's like, got tons of power at it, but it's going against the same back end bucket in S3. So S3, or in this case, it was S3. S3 is really managing the load of our access to the data, which is, that is a well-proven solution. It was one of the first things that AWS offered. It's one of the most scalable. And then by separating out that compute, we
Mhm.
were able to keep the compute distinct and scalable individually. Um, and what's cool about that is you can like choose different instance types for those as well. You can be like, I don't care as much about this workload, so I'm going to use, lower powered instances. This workload I'm really concerned about, so I'm going to give it everything that I can in order to make sure that these queries run really fast. So we had um, 3 query pool set up, one for the, like you said, the more of the engineering, the operational folks that were like digging into very specific things.
Mm,
We had individual dashboards connected to those. We had the exec dashboard that was just one roll up of everything. And then we had that separate pool that we were using for ad hoc. So by running those ad hoc queries, like we didn't have to worry about like, are we impacting anybody else? We'd already completely isolated that workload. So it's both by leveraging object storage and then separating the compute that we can do that without being concerned about how we're impacting anyone else.
sweet. Now that you mentioned object storage, what was the decision to go with object storage rather than use like expensive SSDs? And like, how do you convince like enterprise customers that object storage can deliver performance that they need for real time observability?
Yeah, that's a fun question. So the decision that Hydrolix made to do that was very early on. That was one of the first decisions that was made, was that we want to use object storage because it's a few things. It's consumption based, so you're only paying for what you're storing. Where with an SSD or attached storage, you have to pay for the thing you want to attach, which means the capacity that you want. So whether or not you use it, you're paying for it. So uh, it starts changing the dynamics of the costs there. The second piece, by everything being stateless, um, you can turn that stuff on and off really easily. So, like, a lot of systems will scale up really well, but
Hmm.
when you go to scale down, because they do have attached storage that they're dependent on, you have to scale down very slowly because the system basically has to heal itself after a node drops out of the cluster. And so you
Mm,
can't just be like, "Yep, turn all of that off." So the from the very beginning, it was we want to architect around modern cloud architecture design. We want everything to be as consumption based as possible. And then we use a very specific format as part of our intellectual property that actually makes our retrieval from object storage really fast. Because the main objection with using object storage is like, oh, that's going to be slow. And we compress data a ton. So we can get like, you know, 20 to 50x compression on data as we're going, which is like way more than I think pretty much anybody else in the market. And so then the second piece is, well, if you compress it that much, that's really computationally intensive, and that's going to slow it down too. But it doesn't, because when we store the data, we effectively micro index. We have partitions. Our
mm,
users don't care about partitions, but this is part of what makes this fast. So we have partitions of data that hold data for a table for a given time period. There's a manifest, which describes what's in the file, very small. There's an index that describes where stuff is in the compressed file, which is also very small. And so when we go to pull data back, we don't pull back the whole compressed file and decompress it and then search through it. Our search is actually ask the manifest, is there anything in here I even care about? If the
mm,
answer is no, you're done. If there is, then you pull back the index. In the index, we have byte ranges to where exactly the data lives in the compressed file. So what we pull back is just the byte range, and we only decompress that byte range. So it ends up being really fast. Our customers, like, there's a lot less skepticism because we've had a lot more success now about whether or not we can do that. And there's more understanding in the market of how we do it. But
mm,
initially, for sure, people are like, yeah, right. Like, there's no way you can do this. Like, that it's absolutely impossible. And in fact, like, one of my early reactions to the idea was, I work for another vendor. Every single customer wanted object storage, and our answer was universally that will never happen because it's slow, it's hard, like all of the things that you would expect people to say. Like, we want SSDs, it's going to be really fast. But when you start talking about real time as well, like SSDs are great if you need like less than 10 millisecond response time on something because the data's sitting right there.
Yeah.
For logs that are already seconds old by the time you get them, which is the case with log files most of the time, like they've been generated someplace, they have to be shipped. Having some milliseconds added on to that is not that big of a deal. So most of our queries were coming back in less than half a second
Mm.
or half a second or less during the game. And so that, when you start seeing that, you're like, oh, okay, I get it. Like this actually does speed things up. But most of those logs were already, a few seconds old. So if we're not doing sub 10 milliseconds, but we're still doing sub-second, that's great. Like, that's still fast enough that a human can actually do something about it because ultimately, at the end of the day, a person is going to go fix the problem. And so having like sub 10 millisecond response time for this type of data, it's really neither here nor there. It's like doesn't add that much. If it's 10 milliseconds or 500 milliseconds, it's going to look the same.
Awesome. So with all of that being said, what storage to pick, how many queries, now more like leaning towards the business impact. So in one of the blogs, it mentions that when Fox looked at social media, everyone had good things to say about the game. How do you quantify the business impact of that level of observability?
The business impact was for Fox proving that they could do this. So it was net new to them as well, like live streaming over a network that didn't have a paywall associated with it, being able for themselves to see, like, yes, we actually can do this. We can make decisions in real time gives them the ability to then do much larger events and to be able to do that with confidence that they'll have the observability. For this, it's really the business risk of not doing it well is more of a reputational risk, which
Mm,
has an economic impact, right? If
yeah.
everyone's like, we all saw stuff last year that we were like, wow, that was really bad. Right? Not
You're
mentioning
right.
any names. But it has an impact on, like, is somebody going to pay to subscribe to that thing next time?
Hmm.
If they can't get the video that they wanna see while paying for it, like, and this one wasn't paid for, so it was really an interesting test of, like, how big can this go? So I would say for them, like, it was more it was more of a reputational business risk and then setting them up for success going forward,
Yeah.
and understanding that, yeah, we actually can do this with this much data. I think a lot of folks, our tendency as an industry for so long, because data is expensive, hard to query, all of that, we've gotten used to just throwing data away. So I think there's still a lot to learn. And if I have all the data, like, what can I do with that? Like, we actually ask our customers that question a lot. Like, cool, you want 2 years worth of that type of data. What do you get out of that, right? Like,
Mm.
what do you think is in there? What are you trying to find? And by giving it to them at a significantly lower price, they don't have to have as exact answers to those questions.
Yeah. I think that's brilliant. Um, but when we think about the game or any of these like large scale events, it's not just like big data, but like you said, it's like monster data. So like
Right.
where do you see um the observability industry heading as like data volumes continue to like grow and almost explode?
Yeah. I honestly, we're people have gotten so used to throwing away data that they're like, well, of course I, sample it or I threw that away or whatever.
Mm,
But if you start, like, let's bring AI into the picture here.
okay.
That's where it starts getting interesting. You cannot find patterns if you don't have all the data. You can't find anomalies. Um, if you're only collecting the bad things, you don't, and you want to build models that are predictive about how things are going to go. If you're only collecting a portion of the data, you don't have the full picture. So, like when you're building AI models, you need both positive and negative examples of things. Like you can't just have positive, you can't just have negative. You have to have both of those things in order to come up with a model that's really good. When we start talking about security, also, like security events anymore are not necessarily like these big DDoS things that happen all at once. It's like, you know, people have gotten around that and they'll know things like, oh, well, the security vendor expires their data after 30 days. So,
Yeah.
like, they might do one action here, then they wait for like any observability that the company would have to like fall off, and then they'll do the next event. So, by having that full thing, you can actually see longer term patterns in your data. Not all data is useful for a long period of time, but anything that's related specifically to your business or might have security implications is absolutely needed. And you can tell the difference between people that have suffered security events versus people that have not, because the people that have suffered security events are like, I want all the data forever and ever and ever. And people who haven't suffered security events are like, yeah, it's fine. We'll sample, right? But when you have that thing happen and you need to go fix it, like that's we people that have been through it will understand very quickly, like, yes, I want all of the data. If I can have it and it's cheap enough, I absolutely want all of it. Um, so for us to do a really good job predictively of not just like security stuff, but you know, how our systems are performing, how they're changing over time, you do have to have all the data.
Yeah, that's true. That's awesome. All right. As we get ready to wrap up, just a few more questions. If you had to do Super Bowl 2026 tomorrow, what would you do differently based on what you've learned from the previous Super Bowl?
That's a really good question. I would love a way to simulate that traffic. Nobody's solved that problem yet. That would be a big one. I think uh I think having more time to test different instance types at
Mm,
scale would have been nice. Because we would have been able to see like, response time differences along with cost. We used some pretty, gnarly instances because we could. It was like it's a giant game. We're going to use the big one, so it would have been really cool to understand like what are the limitations there. Um, and then it would have been great to push like the full load that we were expecting or that was possible through the system, even if it was synthetic, um, just so we could see the bounds. Because the way Hydrolix is built, we haven't yet found a bound on like cardinality maximums or storage maximums, especially on something like S3 where there really aren't a ton of limitations.
mm,
Like at some point there are, like there's just physics, but we haven't really hit a lot of those limitations. And so it would be really cool to go back and try to find where they are. Like what's the place where we break, which we haven't found yet.
awesome. And that's good. So, in closing, for companies who are dealing with their own Super Bowl moments, those make or break events, um, where observability is critical, what is one piece of advice that you would like to give to them?
Think about how you're going to use the data. It's not just about collecting it, but it's how are you going to use it and what are you trying to extract out of it? Because knowing that ahead of time will save you a lot of pain after the fact, because you will have done a lot of that computation up front. Um, and then I would say also really carefully look at the data as it's coming in, and make sure, like, it can be something as simple as, this vendor sends this data in seconds and this one sends it in milliseconds. And until you do, like, really deep dive on the data and look at what you're collecting and do comparisons and make sure that, like, everything makes sense, um, it's hard to know that. And you do that by going and looking at the data closely enough to be like, is this correct? Is this what I expected to see? And if it's not, then you usually have a problem. But if it is what you expected, then you're probably doing it right.
Awesome. Well, Catherine, this has been enlightening. I'm grateful for your time. Any parting words that you would like to leave us with?
Go try Hydrolix.
Yes, guys, please go book a demo. Links will be all in the description. Well, once again, Catherine, thank you. It's been a pleasure. And we'll talk to you soon.
Thanks.